C99 is an informal name for ISO IEC 98/99/1999, a past version of the C programming language standard. It extends the previous version with new features for the language and the standard library, and helps implementations make better use of available computer hardware, such as IEEE 750 for arithmetic, and compiler technology. History: after ANSI produced the official standard for the C programming language in 1989, which became an international standard in 1990, the C language specification remained relatively static for some time, while C++ continued to evolve, largely during its own standardization effort. Normative Amendment 1 created a new standard for C in 1995, but only to correct some details of the 1989 standard and to add more extensive support for international character sets. The standard underwent further revision in the late 1990s, leading to the publication of ISO IEC 98/99/1999 in 1999, which was adopted as an ANSI standard in May 2000. The language defined by that version of the standard is commonly referred to as C99. The International C standard is maintained by the working group ISO IEC JTC1WG14. Design: C99 is, for the most part, backward compatible with C89, but it is stricter in some ways. In particular, a declaration that lacks a type specifier no longer has int implicitly assumed. The C Standards Committee decided that it was of more value for compilers to diagnose inadvertent omission of the type specifier than to silently process legacy code that relied on implicit int. In practice, compilers are likely to display a warning, then assume int and continue translating the program. C99 introduced several new features, many of which had already been implemented as extensions in several compilers: inline functions, intermingled declarations and code. Variable declaration is no longer restricted to file scope or the start of a compound statement, similar to C++, several new data types, including long int, optional extended integer types, an explicit Boolean data type, and a complex type to represent complex numbers, variable length arrays, support for one-line comments beginning with, as in BCPL or C++, new library functions, such as smprintf, new headers, such as stbool-h, complex h, tgmath, and int-types-h, type generic math functions, in tgmath, which select a math library function based upon float, double, or long double arguments, etc., improved support for IEEE floating point, designated initializers, compound literals, support for variadic macros. Restrict qualification allows more aggressive code optimization, universal character names, which allows user variables to contain other characters than the standard character set. Parts of the C99 standard are included in the current version of the C++ standard, C++11, including integer types, headers, and library functions. Variable length arrays are not among these included parts because C++'s standard template library already includes similar functionality. IEEE 754 floating point support. A major feature of C99 is its numeric support, and in particular its support for access to the features of IEEE 754-1985 floating point hardware present in the vast majority of modern processors. Platforms without IEEE 754 hardware can also implement it in software. On platforms with IEEE 754 floating point, float is defined as IEEE 754 single precision, double is defined as double precision, and long double is defined as IEEE 754 extended precision or some form of quad precision where available, else double precision. Previously, all C90 floating operations were defined to occur in double precision, with subsequent rounding to single precision. To store results, where necessary, arithmetic operations and functions are correctly rounded as defined by IEEE 754. Expression evaluation is defined to be performed in one of three well-defined methods, indicating whether floating point variables are first promoted to a more precise format in expressions. FLTEVAL method A2 indicates that all internal intermediate computations are performed by default at high precision where available. FLTEVAL method A1 performs all internal intermediate expressions in double precision. FLTEVAL method A0 specifies each operation is evaluated only at the precision of the widest operand of each operator. The intermediate result type for operands of a given precision are summarized in the following table. FLTEVAL method A2 tends to limit the risk of rounding errors affecting numerically unstable expressions and is the design default method for x87 hardware, but yields unintuitive behavior for the unwary user. FLTEVAL method A1 was the default evaluation method originally used in K and RAC, which promoted all floats to double in expressions. And FLTEVAL method A0 is also commonly used and specifies a strict evaluator type of the operands. Note that prior to the precision of intermediate values being precisely specified in C99, C compilers could round intermediate results inconsistently, especially when using x87 floating-point hardware, leading to compiler-specific behavior. Such inconsistencies are not permitted in compilers conforming to C99. Example: the following annotated example C99 code for computing a continued fraction function demonstrates the main features. Footnotes: compile with GCC std = C99 fmath = 387 OTA C99 FPLM test C99 FPC. As the IEEE 754 status flags are manipulated in this function, this pragma is needed to avoid the compiler incorrectly rearranging such tests when optimizing. C99 defines a limited number of expression evaluation methods. The current compilation mode can be checked to ensure it meets the assumptions the code was written under. The special values such as nan and positive or negative infinity can be tested and set. Long double is defined as IEEE 754 double extended or quad precision if available. Using higher precision than required for intermediate computations can minimize round-off error. The main function to be evaluated. Although it appears that some arguments to this continued fraction, for example, 3.0, would lead to a divide by zero error, in fact the function is well defined at 3.0 and division by zero will simply return a plus infinity that will then correctly lead to a finite result. IEEE 754 is defined not to trap on such exceptions by default and is designed so that they can very often be ignored, as in this case, as the raised divide by zero flag is not an error in this case, it can simply be dismissed to clear the flag for use by later code. In some cases, other exceptions may be regarded as an error, such as overflow. STDCIEC 559 is to be defined only if Annex F IEC 60559 floating-point arithmetic is fully implemented by the compiler and the C library. The default rounding mode is round nearest for IEEE 754, but explicitly setting the rounding mode toward plus and infinity can be used to diagnose numerical instability. Note that this method can be used even if compute_fn is part of a separately compiled binary library. But depending on the function, numerical instabilities cannot always be detected. Version detection: a standard macro stdc version is defined with value 199901L to indicate that C99 support is available. As with the stdc macro for C90, stdc version can be used to write code that will compile differently for C90 and C99 compilers, as in this example that ensures that inline is available in either case. Implementations: most C compilers now have support for at least some of the features new to C99. However, there has been less support from vendors such as Microsoft that have mainly focused on C++. Future work: since ratification of the 1999 C standard, the Standards Working Group prepared technical reports specifying improved support for embedded processing, additional character data types, and library functions with improved bounds checking. Work continues on technical reports addressing decimal floating point, additional mathematical special functions, and additional dynamic memory allocation functions. The C and C++ standards committees have been collaborating on specifications for threaded programming. The next revision of the C standard, C11, was ratified in 2011. The C Standards Committee adopted guidelines that limited the adoption of new features that have not been tested by existing implementations. Much effort went into developing a memory model, in order to clarify sequence points and to support threaded programming. See also, C11, C++11, C++ Technical Report 1, Floating Point for further discussion of usage of IEEE 754 hardware, references. Further reading, Cheng, Harry. C99 in Numeric Computing. Dr. Dobbs Journal, Siebsch, Peter. Open Source Development using C99. Developer Works. IBM External links. Final version of the C99 standard with Corrigenda TC1, TC2, and TC3 included, formatted as a draft to PDF 3.61 MB, new in C9X, Core 05 HIN. Are you ready for C99?